We'll start the next problem. So next one, we are going to discuss the problem based on a polynomial defined. Okay. How do you define a polynomial? How do you write a polynomial? It may be finite or it may be infinite also. How do you write a polynomial? General form. It is quadratic. General form. General form, how do you write? Any polynomial p of x is written as a0 plus a1 x square. So a1x plus a2x square plus a3x cube plus etc. General term an x power n plus etc. Polynomial may be finite or it can be infinite also. So this is the general way of representing any polynomial. Okay, if you write it only up to degree 1, it is called as a linear. If you write it as up to degree 2, quadratic. Degree 3, cubic equation. Okay, but this is the general form of writing any polynomial. So next problem we are going to discuss with the assumption that we are going to do the checking for the set of polynomials. So how the elements will be? All the elements will be polynomial. It will be in this infinite series pattern. In the previous problem, how we assumed real numbers are there, how we assume the values to be x, y, etc. Okay, but here it is going to be a set of polynomial. So each variable will be represented in the form of a polynomial. Now, the elements எப்படி இருக்கும்? ஒவ்வொரு elements என்னவா இருக்கும்? polynomial ஆக இருக்கும். So அந்த elements assume பண்ணும்போது எப்படி assume பண்ணணும்? இந்த மாதிரி infinite series polynomial ஆ assume பண்ணினா you have to prove your results. Okay, so for example, how will you add two polynomials? No? How will you add the polynomials? You will add the corresponding coefficients of each one. Okay, so how many x square will be there? 3x. We are adding this. How many x? 5x. Because there is no x to it. So it will be generally 5x. Constant? Yes. Everyone knows how to do add the two polynomials. Yes? When you add two polynomial answers, whether the result will be a number or not, number or any constant. Result. Yes, this is a1, a8, and everything will be going to be a constant value. So when you add two constants, what will be the answer? Constant. When you multiply two constant, constant. What will be the answer? 7x square plus 7. Both answers same or not? If you substitute any x value, whether both answers will be same or different? Same or different? LHS and RHS will be different answer or same answer? Same answer. This is called as our addition and this is called as our scalar multiplication. We are multiplying by a general constant scalar value sum. Okay, only if these two conditions are satisfied, we can apply and check the conditions of the multiplication and scalar multiplication to check for vector spaces. Now, our definition will go first and condition will be addition of scalar multiplication satisfy all. Ana mattume dhaan nam enna panna mudiyum? We can check whether it is going to be a vector space or not. Whether addition and scalar multiplication is possible or not? Yes. So we can proceed with the problem of checking whether it is going to be a vector space or not. Okay. So this we are done with the numbers now. But in our problem, we are going to solve it only with the notations like a0, b0 or c0, etc. Whatever is necessary. Not with numerical numbers. Okay. So take the next problem. Second one. If P of f, capital P of f, denotes the set of all polynomials, in x over field f, comma, then prove that P of f P of F is a vector space. Prove that P of F is a vector space where P of F is equal to set of all polynomials P of x, such that P of x is equal to this format. This is the general form. Comma, AI belongs to F. AI belongs to F. All the A's are coefficients, constant coefficients. So this will be the general form of writing a polynomial. Can I write this infinite expansion simple form? How will you club everything and write? The having infinite is we are going to club and write this in simple form. So what you need to solve? What? Everything is in addition, ma. You want to combine and write this. What is the simple you make? Summation. So what is the general way of writing all this one? This can be written as summation of an x power n ai belongs to F. General way of writing any polynomial. Summation of an x power n that ai belongs to F. Because of the problem we can't write this entire expression and proof for everything. So we are writing a simple proof. Shall we start with the proof? So the statement is clear. What is supposed to prove? Prove that it is a vector space. So surely all the A conditions should be satisfied. If it is not satisfied, means what is the meaning? Yeah, that's a mistake. Because the question is clear now. Prove that it is a vector space. Okay, if you are not getting it as a vector space, means what is the meaning? Yeah, that's some mistake in the logic. Only the question is that check whether the vector space is, whether the given one is a vector space or not, means there is a question mark whether it can be a vector space or not a vector space. But here it is clear, prove that. So all the A conditions should be satisfied. Okay, ma'am? Shall we start the proof? Start the solution. Proof, whatever you want to prove. Right? Let P of x, Q of x belongs to P of f. Set of all polynomials, we are considering two elements, P of x, Q of x. So right, where P of x is equal to summation of an x power n, Q of x equal to summation of bn x power n. The coefficients will be so right, define the addition as P of x plus Q of x is equal to. So already told you how to add it, we are writing it for a general one. Okay. So P of x is summation of an x power n plus Q of x is bn x power n. So when you add, what you will take? Summation of x power n an plus bn, because we are going to add the corresponding coefficients. So an plus bn into x power n. This is how the definition, the addition will be defined in polynomial. When you see the previous problem, the binary operation was given for you. This is how it is related, it is given. But here it is not given, so we are defining because it is a general polynomial with addition symbol. So this should be the rule. Okay, so next one. Scalar multiplication b. Scalar multiplication b. Scalar multiplication b. Alpha into p of x. Scalar multiplication b. Alpha into p of x is equal to alpha into summation of an x power n. How will you write this one? Alpha is any scalar, constant. So we multiply by alpha, how will you write this polynomial? recall the examples again. What we have done? We multiplied that alpha with each coefficient. Okay, so what will be the general form? Summation of alpha into an x power n. Alpha should be multiplied with each coefficient. Come on. Alpha belongs to f. Alpha belongs to f. So we have got this to be the addition law, and this is going to be the corresponding scalar multiplication. Whether the resultant answer belongs to P of f no? Every sonnet. Whether the resultant answer on the particular is value. I will explain you how it is defined. P of x and P of x will be equal to like this. Whether the resultant answer also belongs to P of f, yes or no? And the exam you are going to take and you are going to solve the problem. This is the answer, right? Whether this will belong to P of f or not. What is P of f? Set of all polynomials. Okay, whether this resultant answer is a polynomial or not? Yes or no? Instead of a n, you are having it as a n plus b n. When you add a n plus b n, it is going to be another constant quantity. If you are confusing it, you can assume it will be some c n also. A n plus b n equal to c n. So what will be the answer? C n into x power n. Whether it is a polynomial or not? Yes. So this belongs to P of f. Okay, so our condition is valid because the resultant answer also belongs to P of f. Now go for scalar multiplication. Whether this will belong to P of f? Yes or no? Yes. Instead of constant a n, what we are having? Alpha a n. That is also going to be a constant quantity. So this also satisfies the condition. This also will belong to P of f. Okay, this is the first basic two things you are supposed to verify. Whether addition and scalar multiplication is satisfied or not. Then only you go for all the 8 axes. Okay, shall we start? So right, separating under addition. Under addition. Under addition. So what is the first one you have to prove? Commutativity. How many polynomials are needed to prove commutativity? 2 elements are needed. Here the elements are our polynomials. Okay, right. First one, commutativity. Commutativity. So right, take P of x and Q of x belongs to P of f. Small p of x and Q of x belongs to P of f. Therefore, P of x plus Q of x is equal to. Similar what we have done now. So how do you write this one? P of x is summation a n x power n plus summation b n x power n. When you add, what you will get? Summation of a n plus b n x. What you are supposed to prove now? Commutativity. X plus y equal to y plus x. Here what is the assumption? P plus Q. So what is the right hand side you should take? 2 plus x. Q of x plus P of x. How will you bring from this result? From this you have to show that this is equal to Q of x plus P of x. How can we write? Very simple. I need to write this as Q of x plus P of x. What is Q of x? This will be not good. That's all simple. Who said that answer? Allah. So a n plus b n is the same as b n plus a n. So no. So no. Both are constants, coefficients, constants. So a problems in this error. So do parallel copy. Finish girls. Yes. Second one, what is the second one? Associative. So how many polynomials you have to assume? 3. P, Q and R. Okay, right? Second one, associativity. Associativity, right? Let P of x, comma Q of x, comma R of x belongs to F. Where R belongs to P of F, where R of x equal to summation of Cn x power n. Already we defined in the first step itself what is P and Q. So no need to define that again. So similar way what we did in commutativity, the same logic we are going to apply for 3 polynomials. That's all. So start with LHS. What is LHS? P of x plus Q of x plus R of x. Which two is combined in the LHS? P and Q or Q and R? P and Q. Plus R of x is equal to substitute summation of a n x power n plus summation b n x power n plus summation of c n x power n. How will you write your first term? Summation of a n plus b n into x power n plus summation of c n x power n. So again it is addition of two polynomials. So how can we rewrite again? Summation of a n plus b n plus c n x power n. Okay. Now remember the proof what is supposed to bring. What is the right hand side you have to bring? P plus Q of x plus R of x. Which two should be combined? Q of x and R of x. So try to rewrite this one. This can be written as summation of a n plus b n plus c n into x power n. Because this is only addition work, so we can combine it into this. So this can be written as what? Summation of a n x power n plus summation of b n plus c n x power n. It's just like child play. You are just going to rewrite everything and you are going to arrive at the proof. So what is the first one? P of x. Can you tell me what is the second one? Q of x plus R of x. That's all. Associativity is true. Proof is easy or not? What are you doing? Just rewriting everything and you will arrive at the result. That's all. No other complex steps or nothing is involved. Shall I continue with the third one? What is the third axiom? Identity. What is the meaning of identity? X plus 0 should be equal to x. So, whenever what is the general way of finding identity? If I am going to add any unknown variable to my known variable x, the resultant answer should be x. Then that unknown variable is said to be the identity. Okay, general way is that we call it as E. In our vector, it is going to be the 0 vector. Not completed. Should have told me no. All the others are perfect. Girls, everyone perfect. Boys, anyone who has not yet perfect? 0 plus p of x is equal to p of x for all p of x belongs to p of x. For all p of x belongs to capital P of x. Next one. Let 0 is equal to summation of 0 into x power n. Because we are in a set of polynomials, so 0 should be represented as 0 polynomial, not as a number. Because all our elements should be in what form? Polynomial form. Okay, so write this line. Therefore, 0 plus p of x is equal to. Just to show that it is equal to p of x. Obvious one, but even then we have shown you. So what is our 0? 0 polynomial. So summation of 0 into x polynomial plus what is p of x? Summation of a and x polynomial. How we add it now? We add what we are doing. Summation of 0 plus a and x polynomial. Now in this step it is going to be simply a constant. Okay, so what is 0 plus a and? A. So this is equal to summation of a and x power n, which is equal to p of x. We are proving that 0 is our identity. So right, therefore 0 is the 0 element of p of f. 0 is the 0 element of p of f. Now group plus lo the identity solvom. Field varumbodhu we call the same identity as 0 element. Okay. Written. Now in the same logic, you can tell me about the inverse. The fourth condition is our inverse. What is the condition for inverse? Inverse condition. X plus y should be equal to diagonal. X plus y equal to 0 or x plus y should be equal to identity. என்னோட வேரியபிளோட இன்னொரு வேரியபிள் நான் சேர்க்கும்போது ரிசல்ட் நான் சேர்க்கறதும் ஐடென்டிட்டியா வரும். So come to our polynomial concept. I am having a polynomial p of x. To this I should add some other polynomial so that my resultant answer will be a 0 polynomial. Okay, so what will be the type of my inverse? Others? Minus p of x. Because here the constant is a now. What should be the constant in the next one? Minus a. Here the constant is a1. Minus a1. Then when both will get subtracted and we will get the answer to be 0. So what should we get as our inverse? Minus p of x. Okay, so right. Fourth one, inverse. Inverse. So right. You want me to ask you a question, Isma? Tell me a question, Isma. Listen to the class. So right, for all p of x, already I gave the notations for everything. For all p of x belongs to capital P of x. For all p of x belongs to capital P of f, there exists minus p of x belonging to capital P of f. The symbol is there exists. There exists minus p of x belonging to capital P of f such that p of x plus minus of p of x is equal to 0. Inverse condition. X plus y should be equal to the identity. Just for mark purpose, even though it is an obvious one, you have to prove it, it is going to become 0. Okay, so right, start with the LHS. P of x plus minus of p of x is equal to. How do you write p of x, ma? General polynomial. Summation of a and x power n plus summation of. How do you write minus of p of x? Minus a and x power n. Now how do you add two polynomials? of x. This is like obvious only, but just for steps purpose we have to prove it. Okay. So addition is over. What is the next part? Multiplication. So write separate under scalar multiplication. Under scalar multiplication. Under scalar multiplication. What is the first one now? Alpha into x plus y is equal to alpha x plus alpha y. Instead of x and y, we are going to make use of as p of x and q of x. So right. First one, let p of x comma q of x. Let p of x comma q of x belongs to capital P of f. Belongs to capital P of f and alpha belongs to f. Alpha belongs to f. So start with LHS. Alpha into p of x plus q of x is equal to. How do you rewrite this one? Alpha into summation of an x power n plus summation of bn x power n. P of x and q of x. Substituting our polynomial. So if multiply alpha inside what will happen? Summation of alpha an x power n plus summation of alpha bn x power n. Just multiplying the scalar inside each polynomial. This first polynomial can be rewritten as alpha into summation of an x power n. Can we write? Both are same or different? Same, because alpha is going to be in all the coefficients, we can take it outside. Similarly, second one, alpha into summation of bn x power n. But what is an x power n? P of x. So this is equal to alpha p of x plus alpha q of x. Shall we go for the second one? We got it done. What is the second one? Alpha plus beta into x is equal to alpha x plus beta x. We are going to prove that with two scalars and one polynomial. So start with the second one. Second one. Alpha plus beta into p of x. Alpha plus beta into p of x is equal to. So multiply is only a scalar. So how do I first step? Alpha plus beta into summation of an x power n. Substituting here p of x. How do you rewrite this? Now, scalar is alpha plus beta. If you multiply it inside, alpha plus beta into an x power n. Okay, now these are going to be only scalars and ordinary addition. So how can I rewrite this? Summation of alpha an x power n plus summation beta an x power n. Okay, since it is only ordinary addition and multiplication. How do you rewrite this one? Scalar alpha, the summation will be comma. So if we take outside, what is the remaining? Is the taken alpha outside. So what is the remaining? Summation of an x power n. That is nothing but what? P of this. Plus, similarly beta is a scalar. We will take it outside as summation. So beta into Q of x. P of x. An x power n is again P of x. So this is what you are supposed to prove. Can you prove for multiplication, ma? What is the third one? told you all this logic now, simple one. Start with the LHS, identify what is the right hand side you are supposed to prove. According to that one, rewrite your tools. That's all. Next. Bring the scalar along with the constant. So how can we write? Summation of alpha, beta, an, x. What you are supposed to prove now? Alpha is a separate one. Beta should be combined with p of x. So how do we write this one? Summation of alpha into beta, an, x power n. Alpha should be separated. Okay, the other two terms are combined. Whether this three product and this three product are same or different? Same. All are scalars only. So it will be same. So from the summation you can take alpha outside. So alpha into summation of beta an x power n. Okay, alpha into all these things. Okay, what is the next step you can do? Alpha into. From this summation, beta can be taken outside. So beta into. What is the remaining? P of x. Summation of an into x power n will be P of x. That is the proof we are supposed to do. Those who completed, start with the fourth one. Multiplicative identity. Shall we start with the fourth one? What is the fourth one you are supposed to prove? 1 into x should be equal to x. Okay, then 1 is called as the multiplicative identity. Here instead of x, you are going to deal with the polynomial. So you have to show that 1 into p of x should be equal to p of x. Okay, so write fourth one. To prove, as I will copy this one. Shall I erase? Anyone still copy? So 1 into p of x should be equal to p of x. That is what you are supposed to do. Okay. Already we discussed the additive identity 0. Okay. Remember that how we discussed how should be 0. 0 should be written as a polynomial. Now tell me how this 1 should be written as a polynomial now. What should be the nature of that polynomial? 1. I find a number 1, but this number 1 should be written in a polynomial formula. Summation 1 into x power n. What about others? So if I expand this one, first value n equal to 0. So what you will get? 1. When n equal to 1, n equal to 1, x. When n equal to 2, when n equal to 3, etc. Whether this is equal to 1, you get a value 1 maybe. I should rewrite 1 as in terms of a polynomial. Whether this is right? Yes or no? No. How it is right? Why read as 1 one constant 1. When we expand பண்ண என்ன வரும்? 1 plus x square plus x cube infinite series. So this is not a right form. So what should be the correct form of writing as a polynomial? The constant மட்டும் தான வரும். Constant 1 மட்டும் தான் இந்த ஆன்சர்ல வரும். ஆனா மிச்சம் இருக்க கான்ஸ்டன்ட்ஸ் எல்லாம் என்னவா இருக்கும்? Okay, what is the general way of writing a polynomial? General a0 plus a1x plus a2x square plus a3x cube etc. a0, a1, a2 etc. are coefficients or constants. Okay, வேற ஞாபகம் வச்சுக்கோ. இதுல இருந்து எனக்கு ஆன்சர் 1 தான் வரும். அப்படினா என்னோட a0, a1, a3, a3 னா எப்படி இருக்கும்? The general polynomial is a0 plus a1x square plus a1x plus a2x square plus etc. This is the general way of writing a polynomial. I need my answer as 1. Okay, what should be the nature of a0, a1, a2, etc. Please remain in silence. Last bench, third person here. From this side, third person. Yes or no, Lima? Tell me the answer. Yeah? Tell me the answer. The other two persons also be ready with the answer. Next one. Next one. The next one. What is the answer? Give me the answer. You know all the answers, so you are busy talking there. You don't want to listen to the class. So give me the answer. You know very well the answers. There is not any necessary for me to teach you people. So give me the answer. Yes, ma'am. Others, what should be the answer? What should be the nature of a0, a1, a2, etc. ma'am? Take that you have 1 and number 1 is the number 1 and our polynomial form is okay, wow. 1 and in the formula. Okay, so in the formula simplify பண்ணா எனக்கு ஆன்சர் வந்து 1 வரும். அப்படினா என்னோட a0, a1, a2 தான் என்னவா இருக்கணும். இப்போ zero polynomial means what is said, ma'am? All the coefficients are 0. So we get it as a zero polynomial. அதே லாஜிக்ல யூஸ். I need my answer only as a constant 1. அப்படினா என்னோட a0, a1, a2 தான் எப்படி இருக்கணும்? Which one should be 1? a0 should be 1. a1 say louder 0. a2 0. And all the other coefficients should be 0. Only the constant a0 should be equal to 1. All the other coefficients should be 0. So this is the way how I can represent the number 1 in terms of a polynomial. Can you understand? Yes? What about you think? Understood now? Will you listen to the class or you understand? Will you listen to the class or you want to continue standing till the buildings? Sit down. Right. 1 is equal to, right, 1 is equal to 1 plus 0x plus 0x square plus etc. This is how we are representing number 1 in terms of your polynomial. So start with the LHS. Therefore, 1 into p of x is equal to 1 into p of x is equal to 1 into summation of a n x power n. A n x power n. So now it's like scalar multiplication now because 1 is a constant. So we multiply inside what will happen? Summation of 1 into a n x power n. Okay, but what is 1 into a n? A n. So this is simply a summation of a n x power n which is equal to p of x. Okay. Here, even though we write it as 1, it is not a number 1. It represents the polynomial format. Here, we set it the polynomial. It is not infinite polynomial. Okay, understood, ma? So what is the conclusion you can get? Which is the multiplicative inverse? 1. So right, therefore 1 which is equal to 1 plus 0x plus 0x square plus etc. Yes, the multiplicative inverse. Yes, the multiplicative inverse. Whether all the conditions are satisfied? Yes. So what is the conclusion you can give? Hence, V equal to P of F is a vector space. So that hence P of F is a vector space. P of F is a vector space over F. P of F is a vector space over F. Determine whether the set of all 2 by 2 matrices, set of all 2 by 2 matrices of the form first row A plus B, second row A plus B, A. This is how the elements are defined in our 2 by 2 matrices. Comma A comma B belongs to R. A comma B belongs to R. Continue. With respect to standard matrix addition, and scalar multiplication, yes, a vector space or not? Who is that one? Yes, a vector space or not? If not, continue the question. If not, list all the axioms. If not, list all the axioms that fail to hold. So here they are giving a checkpoint. You can't be sure that whether it is going to be a vector space or not. If it is not going to be a vector space, you have to give the list of all the axioms which is not going to be satisfied. Okay? Settled, no? So what is the type of matrix given for you? Square 2 by 2 matrices, 2 rows and 2 columns. Whether the elements are in general form, no? Now the order matrix is the elements separately. A, B, C, D, A11, A12, A21, A22. But here the elements are specified in a particular form. How the elements are defined? A plus B, and A. So this should be the format of the elements, whatever you are going to choose. Okay, so now assume panna matrix set elements ellame eppadi irukno in the format la da irukno. You should not choose any other format. For example, I assume this to be the matrix A. Okay, what should be my matrix B? What will be next element B? A2 plus B2, A2 plus B2, A2. So a set like the matrices or elements ellame eppadi irukum only in this format only. Okay, so now we are supposed to give the proof by assuming the elements of this format. Okay, last problem enna pannom, all the elements we assume to be a polynomial format and we gave the proof. In the same way, we have to assume all the elements into this matrix format and we must give the proof for all the indices. Okay, what is the binary operation given here? What is the operation mentioned? See the statement. Very different when you come back. Standard matrix addition and scalar multiplication. Normal addition of matrices and multiplication of matrices. No specified operations are given. In the first problem, specified operation was given. Here it is normal addition and multiplication of the matrices. Okay. Shall we start with the proof or solution? Right. Let B is equal to let B equal to the set of all elements of the form, like a 2 by 2 matrix form, A plus B, comma A, such that for all A, B belongs to R. For all A, B belongs to R. This is a vector space B. Okay. Now, right? So first, what is supposed to check, ma'am? Before going to the axis, what is supposed to check? Whether the addition and scalar multiplication is wholly good or not. What is the meaning? The resultant answer should belong to B. We have to check whether it is satisfied or not. Then only we can go to the axis. So, right? Let A comma B belongs to B. Let A comma B belongs to B. A is a 2 by 2 matrix, B is another 2 by 2 matrix. Tell me what happened to A plus B, ma? Whether it will belong to B or not? It will belong to B or not? Is that the same problem? Yes, because it is going to be a 2 by 2 matrix. When you add 2 by 2 matrix, the resultant answer is also going to be a 2 by 2 matrix of the same form. Then a element add பண்ணும்போது the corresponding add பண்ணுவோம். Now resultant answer அதே form ல தான் இருக்கு. So it just belongs to B. Okay, so that when A comma B belongs to B, that implies A plus B belongs to B. A plus B belongs to B. Next one. Let alpha belongs to R. The F will be divided to be R. Here numbers. Alpha belongs to R. Then alpha A belongs to 10. Scalar multiplication. And multiply this matrix A to be some scalar alpha. Okay. Whether the resultant answer will belong to B or not? Yes or no? Whether the resultant answer will also be a 2 by 2 matrix, no? Yes, so that also belongs to B. Directly you can say no, we can do it. Alpha A belongs to B. Because it's only normal matrix addition and multiplication. So now we start with the axioms. Subheading under addition. Under addition. Under addition. What is the first one you are supposed to prove? In a pair, commutativity. Put the title. In the exam you write it, you put the title as commutativity. The rule. Okay. Then you write to prove x plus y equal to y plus x then. But here it is going to be a matrix. So what are you supposed to prove? A plus b equal to b plus c. Then you start with the elements. Here I may skip those steps, but in the exams you write all those steps. Okay, so first one, let A comma B belongs to B. A comma B belongs to B. That is A equal to, right, as 2 by 2 matrices, A1 plus B1, A1 plus B1, A1. This is the format of the matrix B. Similarly, write as B, A2 plus B2, A2 plus B2, A2. So commutative means what you are supposed to prove? A plus B should be equal to B plus C. So start with LHS. A plus B. A plus B is equal to A1 plus B1, A1 plus B1, A1 plus A2 plus B2, A2 plus B2, A2. Everyone knows matrix addition, right? Tell me what is the answer to matrix addition? A1 plus A2. Next. A1 plus B1 plus A2 plus B2. Second row. A1 plus B1 plus A2 plus B2. Last element. A1 plus A2. Normal addition. Add the corresponding elements. What you are supposed to prove? You have to prove that this is equal to 9 plus. Then how will you rewrite this one? There is only how many addition? No. Yes, these are only 8 ones. Whether A1 plus A2 is same as A2 plus A1? Yes or no? Whether addition of this one and this one is same as the reverse or not? Yes. Now last step we know B plus A1. हमने इनके इमेजिनरी फ्रेंड का प्रूव किया. A2 B2 should be written as first and A1 B1 as the second one. Just rewrite it. This is equal to A2 plus A1, A2 plus A2 B2 plus A1 plus B2. Similarly this one. A2 plus B2 plus A1 plus B1. Last one, A2 plus A2. Because all are elements and it indicates only obviously addition. So you can rewrite it. So to prove that this is equal to B plus A1. How is we can write this matrix? All A2 B2 goes to be as one matrix. And all the A1 to be the other matrix. So how will you write? A2 plus B2, A2 plus B2, A2 plus A1 plus B1, A1 plus B1, A1. Just rewrite according to the result what is necessary. So this is equal to what? A plus C. So commutativity is true. Commutativity is true. Shall I read associativity to you, ma? How will you prove that? Okay, say it in terms of matrices. We are now in matrices. A plus C should be equal to A plus B plus C. Start with the LHS. What is our LHS? A separate plus B plus C. Okay, substitute all the three matrices. How will you assume C, ma? A3 plus B3, A3 plus B3 and A3. Okay, you write A separately. Then B plus C together. Add both. Okay, that resultant answer you add with A again. Okay, so you have completed A plus B plus C. Okay, normal addition. What should be the RHS you are supposed to prove? A plus B plus C. हमने इनके terms नहीं combine பண்ணி ஒண்ணா எழுதணும். A terms B terms. A ना इधर combine பண்ணணும். A1 and B ना A2 B. Okay, so you combine all the terms of A1, B1, A2, B2 together. So C will be separate. Then you can relate it to the corresponding RHS. Can you complete that one associativity? Yes. Put a subtitle and leave space for that. Leave space, otherwise you will not fill that one. What is the third one you are supposed to prove? Identity. Okay, can you say what will be the identity here, ma? What identity matrix? One. Whether it will satisfy, what is the identity condition? X plus y should be equal to E. Okay, we don't know what is E. Okay, but you solve it 1, 1, 1, 1 now. If you add A plus B, whether it will be equal to 1, 1, 1, 1. What is A? A1 plus B1, A1 plus B1, A1. Okay, or B அதே மாதிரி. Whereas we add 4, whether the answer will be 1. So directly we don't know what is our identity. Okay, well, previous problem was a polynomial. So we will be able to write 0 as a 0 polynomial, so it was a direct one. But here we can't tell what will be the identity directly. So as we did in the first problem, we had assumed it to be a general key format. Solve it and find what will be the identity. புரியுதாமா? எல்லா ப்ராப்ளத்துக்கு ஐடென்டிட்டி ஒரு டைரக்டா தெரியாது. ஓகே, ஜெனரல் மேட்ரிக்ஸா இருந்ததுன்னா நீ சொல்ற மாதிரி 1 1 1 1 ஐடென்டிட்டியா வரலாம். ஆனா இது ஒரு ஸ்பெஷலைஸ்டு ஃபார்ம். இதோட எலிமெண்ட்ஸ்லாம் எப்படி இருக்கு? a a plus b a plus b a இருக்கு. ஓகே, இதுக்கு ஐடென்டிட்டி எப்படி இருக்குங்கிறது நமக்கு தெரியாது. ஸோ இந்த மாதிரி ப்ராப்ளம்ஸ் வரும்போது என்ன பண்ணணும்னா ஐடென்டிட்டி ஈயை ஜெனரலாக அசியூம் பண்ணிட்டு அந்த ஈக்குவேஷனை சப்ஸ்டிட்யூட் பண்ணி சால்வ் பண்ணி யூ ஹேவ் டு ஐடென்டிஃபை வாட் இஸ் இட். ஓகே, ஸோ ஸ்டார்ட் வித் தி தேர்ட் ஒன். Identity. Third one, identity. That exists. 0 belongs to B such that 0 plus A equal to, that is our identity, such that 0 plus A equal to A. So right, take 0 is equal to, let 0 is equal to, we don't know what is the nature of 0 mark, so we are going to assume it in a general form. Okay, let 0 equal to E1 plus Z1, E1 plus Z1, E2. We assume it to be general form, array form. A plus B, A plus B, A. So now we have to substitute this in this condition. We have to solve it and we have to find what is your E1 and what is your Z1. So right, 0 plus A equal to A. So that implies substitute E1 plus Z1, E1 plus Z1, E1 plus A matrix A plus B, A plus B, A. That should be again equal to A. So A plus B, A plus B, A. Substituting in the identity condition. So now we will add your LHS. What you will get? E1 plus A. What will be a second element? E1 plus Z1 plus A plus B. What will be a third element? E1 plus Z1 plus A plus B. Third element, E1 plus A. They should be equal to A plus B, A plus B, A. So from this, what you can say now? How will you find E1 and Z1? I told you that LHS is equal to the RHS. So what you can say from this? E1 plus A1 should be equal to A. E1 plus Z1 should be equal to A plus B. Find E1 and Z1. Find it. That is equal to A1. It is not A1 from A2. They are similar to A1. It is not A1. Find what is E1 and Z1. Let's say it out 0. So E1 plus A equal to, you combine this two. E1 plus A is equal to what? A. So what is E1? 0. Now the next one what you can combine is this two. Minus. So E1 plus Z1 plus A plus B equal to A plus B. Okay, the second element. So what will happen? E1 plus Z1 equal to 0. Okay, but already you got E1 to be 0. So what will be Z1? 0. So what will be Z1? 0. So what we have a Z1 zero. So both E1 and Z1 should be zero. Then only it will become as our identity. Can you understand now? So all the problems you can't directly identify the identity. Check it by using the condition. Okay. So right. Hence 0 equal to 0 0 0 0. Because both E1 is 0, Z1 is 0. Yes, the identity. Yes, the identity. Yes, the identity. Yes, the identity. Can you how do you find the inverse one? How do you find the inverse? What is the condition of inverse? Before that, any doubt in this one? No? So what is the inverse? Condition x plus y should be equal to